Hello and welcome to episode 14 of the Notecard Review. The topic today are the Okazaki fragments, which is something that only occurs on the lagging strand of the DNA during replication. Right? So this is a specific topic that has some additional complexity, so I'm just going to focus on that here. And there are other videos on the broader topic and on more details. As a reminder, DNA and RNA are read, running from 3' to 5', and written from 5' to 3' ends. Okay. On these illustrations, I've got the DNA shown in blue and RNA fragments shown in green. And what we're looking at here is a replication fork with it opening here in the center of the screen. And this bottom strand is the one that we're focusing on today as the lagging strand. Okay, and you'll see that the 3' end is here to the left, 5' end is to the right. Okay. The first thing that has happened at that origin point is that primase has come in to bind a primer of RNA nucleotides to the existing DNA strand. Okay, remember this is the lagging strand. Okay, so primase is coming in and adding primer 5' to 3'. So it's moving in this direction, okay, back toward the origin point. So this molecule is moving here from left to right on the screen. The next thing that happens is that a DNA polymerase III enzyme is going to come into the 3' end of a RNA primer that the RNA primase has already added, and it's going to bond to this 3' end and start adding DNA nucleotides 5' to 3'. So again, reminder that it always is written or created 5' to 3'. Okay, so we've got our RNA showing here in green that was added by the primase. DNA polymerase III coming in and adding the blue nucleotides in as DNA. Okay, so remember this is attached here at this 3' end of the primer. Okay, the complication comes when you realize that DNA polymerase III is going to run into another primer that's back here closer to the origin point. The end of that primer is going to be the 5' end, which DNA polymerase III can't attach nucleotides to. It can't form the bond that direction. It's simply not how it's designed. So what happens instead is the DNA polymerase III is just going to release, and a different enzyme is going to come in and finish the process instead. So what happens instead is that DNA polymerase I comes in and starts replacing the RNA primers, and then the ligase is going to come in and actually bond that 5' end and 3' end of the old primer location with the existing DNA that the DNA polymerase III added. So it creates that version of the phosphodiester bond here along the backbone of the DNA strand that the DNA polymerase III couldn't do.